So, okay, children, whatever. Sometimes this is very bright, sometimes it's not. Sometimes this, I think, because of this rainfall, also it happens, right? Isn't it? This wireless is like this. Class 10. Class 10 is here. Okay, children, this, right? Metal one. It is also one fourth of that one. Near about 2000 rupees. That's cost 8,500 rupees. Could you remember what did we discuss yesterday? About image formed by convex lenses, right? How many positions are there? Six positions. What is the first position? Infinity. Object at infinity. Where is the image formed? At principal focus. Object infinity, image at principal focus. Object beyond 2f, object in front of 2f. Opposite. Object at 2f, image at 2f. Object between f and 2f, image beyond 2f. Object as f, image at infinity. And object between f and o, where is the image from? In front of convex lens. So those positions you have to remember. What happened? This became Simresh Maharjan. Let's come here. After Simresh, please be ready. Who's turn? Acharya's turn is there. Anything is there? Okay, I'll just take that.
So namaskar everyone. So I'm going to discuss about the chapter lenses. So there are two types of lenses. There are convex lens and concave lens. Convex lens. The convex lens is a lens that converts rays of light that convey parallel to its principal axis. That is, converts the incident rays toward the principal axis, which is relatively thick across the middle and thin at the lower and upper edges. Next is concave lens. So a concave lens is a lens that diverges a straight line beam from the source to the diminished upright virtual image. It can from both real and virtual images also. So concave lenses have at least one surface curve inside. So here is the figure of these concave lenses. So some images are given on normal convex lens and two prisms base to base. So in that figure, a lens consists of a number of sections of a prism, but for a better understanding, G of this concept, arrangement of two prisms is described here. A convex lens can be considered as two prisms connected base to base. As we move towards the edge, as the prism from the middle or the angle of the prism increases, as the angle of this increases, the deviation of rays close also increases. Thus, if a parallel beam of light falls on a prism, the incident rays close to the base of the prism bend less, while the incident rays close to the edge bend more. So next one is some terms related to lenses. Optical center. The optical center of the lens is defined as the point which lies on the principal axis through which the rays of light passes without any deflection, or it can be defined as the central point of the lens through which a ray light passes through suffering any deviation. So here is the pictures of optical center also. Next one is the center of curvature. Center of curvature, the center of sphere of a part of which a lens is formed is called the center of curvature of the lens. Since the convex and concave lens are formed by the combination of two spheres, therefore they have the two centers of curvature. Distance between the center of curvature and surface of lens is called radius of curvature. Next one is the radius of curvature. The curved surface of lenses are two spheres. Center of these spheres are called the center of curvature. Distance between the center of curvature and surface of the lens is called radius of curvature. A lens have two radii, radii 1 and radii 2. Principle of axis. The principle of lens is the line that passes through the geometrical center of the lens and joins two center of the curvature of its surfaces. Sometimes the principal axis of a lens is also called optical axis. Next one is the principal focus. The principal focus of the lens is generally defined as the point at which the rays passing parallel to the principal converge in the case of a convex lens and appear to diverge virtually in the case of concave lens. The point on the axis of the lens are mirror to which parallel rays of light converge from which they appear to diverge after reflection or refraction. Thank you.
Wow. What a lovely animation. Right? Give him a big round of applause. Considering they prepare slides without anything. Some prepare with anything. But he has added some next thing. Emotional, right? Yes, that's great. So some terms were discussed and what a lovely things that have been done. Actually, how long does it take to prepare? How much time did you consume for this?
10 minutes.
Within 10 minutes, you know. Wow. See?
This
And whatever it is, how much time does it take for you? Half an hour. You think that? 15, 20 minutes. Result? Actually, what you have to do is you have to do animation of it. It's very good. Understood? Otherwise, there's no difference between this word and understood? If you are able to give your emotion, then that is what. My daughter, she has to prepare on thesis work and she has to do some research. In PowerPoint, she made video. One person was talking, the saying something, another was replying. Conversation was also made. It's a matter of interest. So it will be time. And if you make this type of slides, it is very much beneficial for you also. You can do well. And I'm hearing some positive coming from the guardians as well. So they are little bit improved in comparison to earlier. For some guardians, they say that, well, my son or daughter wants to have mobile for a long time. So within half an hour, you can complete all the work. Can you complete that? That's why don't complete more than that. Right? Okay, so these things were discussed yesterday as well. Now, just see once again, what did he say? The principal purpose. So, how long did I get from here? So, this principal axis is black. And what are these blue color, red, these are the rays of light. And when they strike with convection, they meet. And that point is called focal point or principal focus. And what is this distance called? Focal length. Right? So these points were discussed. Okay.
Namaskar everyone. Today I'm here to representation on the topic of image formed by concave lens.
Concave lens. Okay.
A concave lens always forms a virtual, erect and diminished image whatever is the location of the object. If the object is erected, it is real object, and if the if object is downward, it is virtual. Object between infinity and focus. When an object is placed between infinity and the focus of a concave lens, the image is formed at any point in between the focus f and the optical center O of the lens. The image that thus formed is virtual, erect and diminished. This type of image is formed by the lens used in a people, as you can see in the figure. Second is object at infinity. When an object is kept at infinity of a concave lens, the image is formed at the focus f. The image is virtual, erect and highly diminished.
Wait, that's the mirror, I think. Then mirror, no? Then mirror or lens? I'm confused. Then mirror, right? Not lens, right?
This is mirror.
From different. There is convex lens, mirror. Oh, yeah.
New Cartesian sign convection for lenses. The following new Cartesian signs of convection is used for measuring of the ray diagrams of both concave and convex lenses. First is focal length of a convex lens is positive, whereas the focal length of the concave lenses is negative. Since an object is kept above the principal axis, the height of the image formed above the principal axis is positive. Height of the image also shows an erect image. Third is the height of the image formed below the principal axis is negative. Height of the image also shows an inverted image. Magnification. Magnification of an image indicates how small or large the image formed by in a comparison to the object. Thus, the magnification of a lens is defined as the ratio of the height of the image to the height of the object. Mathematically, there is also formula by it. Height of image by height of object. It is denoted by capital I by capital O. The size of the image produced by the lens depends on the distance of the object from lens. If an object is placed near the lens, the image is magnified. If the object is way away from the lens, the size of the image is diminished. Thus, magnification also can be calculated by the ratio of the image distance to object distance. Mathematically, there is also another formula by it. Distance of image from the lens by distance of object from the lens. Magnification m, distance of an object from the lens u. Now attempt to explain why an aeroplane appears large when it is close to us, but the aeroplane appears smaller and smaller as it flies away. Why does this phenomenon occur? Interpretation of magnification equals to 1 indicate that the height of the image is equal to the height of the object, or the image distance is equal to the object distance. First is magnification m less than 1 indicates that the height of the image is less than the height of the object, or the image distance is less than the object distance. Second is magnification m is more than 1 indicates that the height of the image is more than the height of the object, or the image distance is greater than the object distance. Third is negative magnification shows that the image is virtual or erected. Fourth is positive magnification shows that the image is real and inverted.
Yes.
Thank you.
Thank you. Okay. Uh, in this period, there is only presentation from Sasank Acharya. Next period, there will be presentation from Sasank Lamsal. Okay, just be prepared. So, what did he discuss? So, once let's discuss here. Oh, wait. Why has he gone? Yes. Why has he gone? I think it's gone, right? So I will connect once again. I will connect once again. Connected? Yes. So, children, look at here. We are continuing this one. Image formed by concave lens. Especially, uh, there are 6 positions in convex lens, but in case of concave lens, there we have to discuss only 2. One is object at infinity, where or object between infinity and lens, right? So always you have to keep in mind this concave lens makes virtual, erect and diminished image. Virtual means not formed by the actual intersection of refracted rays, erect upward, and diminished means smaller than the object. For example, see here, what is this line called? Principal axis. If there is lens, then this is principal axis. If the image is formed below the principal axis, that is real and inverted. Below the principal axis, real and inverted. If it is formed just above, what is it? Erect and virtual. And for that, you have to compare whether that is magnified or diminished. If bigger image is formed, magnified. If smaller image is formed, diminished. Okay. But it is 100% clear that concave lens forms virtual, erect, and diminished. Virtual, so whatever image is this, virtual, erect, as well as diminished means smaller. Suppose if this is object, image will be like this, smaller, in the same size, right? Okay, so there are some positions we have to remember. First one is object between infinity and focus. Now see here, children, you have to practice this thing. Draw here concave lens. What is this? Concave lens, and you can draw here straight line. What is this point called? O. O to here. What is this? Principal focus. Here is 2F. One thing you have to remember, this distance is also called R, radius of curvature. What can we call it? Radius of curvature. So object between infinity and focus means object is here. Object is here. Now how to draw the image? So parallel line is here. It is convex lens or concave lens? Concave lens. In case of concave lens, this ray does not go next side. Yes or no? Just be careful. Eh? It goes up to here, then from here, diverging lens, right? One ray goes parallel to principal axis, another ray goes from optical center. This is dotted line, and what is formed here? Image is formed. Where is the image formed? Between F and O. Always image is formed between F and O when the object lies between infinity and focus. If not, so let's try another one. What is here? What is here? Okay, suppose object is at 2F. Eh? What is the object? At 2F. One ray of light goes parallel to it, this one. Another must go from, where the image from? Same place or not? Suppose here is object. Now, goes parallel and then goes from here. See? If the object lies between infinity and focus, where is the image from? Between focus and optical center. Please remember, right? Between focus and optical center. What type of image is from? Image is virtual, erect, and diminished. Virtual, it is not formed by actual intersection. Erect, upward, in front of the lens, and diminished means smaller than the object. Object is bigger, image is smaller. These are the conditions. Okay. Now, second one. What is second? Where does the object lie? Object lies at infinity. So this is not the diagram. This diagram is wrong. Understood or not? This is the diagram of convex lens. Sorry, mirror. This is mirror. There must be lens. So while copying, so they might have copied from somewhere else. So what type of diagram will be there? So let's see the diagram. So what is this? Children, what is this? Concave lens. If you make like this and mark here O, and what to mark here? F. I said O to F. What should be the distance? 2 centimeter. While drawing, please draw carefully. Eh? F to 2 centimeter. Here also let's mark here F, but the ray of light doesn't go here. Where is the object? Infinity. Infinity. Suppose it is here. Infinity means far, very far away. How many rays of light are coming? 2. So this ray of light cannot go to next side, but here to here join with straight line, diverging or not? Here also. Where are they meeting? Where are they meeting? At F or not? So what is this? Image. When the object lies at infinity, where is the image formed? At focus, in front of the lens, not behind the lens, in front of the lens. What type of image is formed? Image is virtual. Virtual means, see, it is formed by not actual intersection of refracted rays, erect, and what is given here? Highly diminished, very small in size. Virtual, erect, and highly diminished. Okay. Here is given some points to remember. We discussed last time also. Focal length of convex lens is positive. Focal length of concave lens is negative. Focal length. So if we write like this, then we can consider convex lens. What is this? Convex lens. What is this? Concave lens. Concave lens F, U, and V. What is F? Focal length. What is U? This is object distance. Are you feeling sleepy? This image. Are you feeling sleepy or not? You pull your ear. 1, 2, 3. If you cannot, then consult to me. I will just pull. Very simple technique there. Those who are feeling very sleepy, what to do? You pulling here. Changa. That is called DC. Okay, what is that called? DC. Dimag changa. Otherwise, my panka. Remember it? You know it. School's vice captain. Morammat was done there. What is U? What is V? In case of convex lens, this is positive. This is negative. This is positive. This is also positive. This is negative. This is also negative. Oh, this is positive then. Convex lens, all are positive. But concave lens, except object distance, others all are negative. Next one is your magnification. What is magnification? Magnification is the ratio of height of image to height of object, or ratio of object distance to image distance, or comparison of size of image. How big or small size is there of image, right? For example, if I write magnification is greater than 1, or magnification is equal to 1, or magnification is less than 1. Three conditions are there. Right? Magnification greater than 1. What does it mean? Image is bigger than object. What is that? Magnification equals to 1. They are of equal size. Equal size. And magnification less than 1. Image is smaller than object. These things you have to remember. Just that much only. Magnification greater than 1. Magnification less than 1. Magnification equals to 1. So, in case of convex lens, there may be magnification greater than 1, less than 1, or equal to 1. But in case of concave lens, magnification is always less than 1 because small size images. Is it okay? So that is the end of today's discussion. Now your duty is to read once again and prepare note and be ready to listen the sweet speech of Sasank Lamsal in next video.